So numerical Python or NumPy is a package which can efficiently handle vectors and matrices, which means similar to list that we were discussing. So the first thing that we have discussed last time is the difference between a list and NumPy arrays, and we already know that lists are we define using square brackets with comma separate values. In numerical Python NumPy, we first import NumPy as NP, means we will shorten NumPy as NP, and the first method is we will create this arrays or in this particular case using np.array, and the values are actually put it as a list, right? So this is how usually we will put a simple list which defines as a numerical Python array, which is more efficient. People say when you can see the efficiency improvement when you work with very large matrices. So today we will discuss how you automatically create matrices, and there we could discuss more into details. Right, so that's the first thing. From this point onwards, we are going to represent data as numerical Python or NumPy arrays. Right, so last time we started looking at one-dimensional arrays, which means basically lists. So row vectors, for example, we can have as a single array. In this particular case, we have 4 elements here, and this print statement will actually print this, right? So in numerical Python, and also when you use the Colab environment, when you type the command and when you run it, you will get the result. So here is the output when you print it. Second statement is a type. The type of this, once you actually use numerical Python array, it will create a NumPy n-dimensional array object, right? And then there are other common things we discuss. Few things that we discussed last time, that is we discuss the shape of an array. In this particular case, we have 4 elements, number of elements using a.size, and then accessing elements. I discussed couple of things here. For example, you can access first element using a0 because it's a ordered collection here. So a0, a1, a2, a4 and so on. And we can make slices as well. Remember the ideas that we have discussed in string manipulation. So this is to get the first 2 elements. Here we don't have specify any value, but this goes from 0 to 2. And then backward indexing we have discussed last time. So to access the last element, you can simply say a minus 1, right? So these are the ideas that we have actually discussed last time. So today I am actually shared you this handout. If you didn't get this handout, you can visit Google Classroom. So I have everything is put it here. Actually the note is prepared using the Colab environment. Whatever we type, we can save it as a PDF file. So that PDF I have shared with you. You can see these are the operations that we are going to use, right? Okay, so to access this one, if you do not already have, go to Google Classroom. I have asked you to log in everyone about this course on Python programming for machine learning number 4. And if you go to classwork, under handouts, I have put NumPy, so you can actually download this handout from here, right? I hope everyone is got the access. Can you download this please, so that actually you can cut and paste. Sometimes we can save some time. right? Can you download it and open the file? So it's easier for me to, explain. Once you finish this, can you please raise your hands? Those who access the Google Classroom, first download. This is the handout, and it lists all the commands that I am actually going to demonstrate today. Please download it, open it, and if you finish, please raise your hand so that I know that everybody is having the access to the handout. Right, about half of the class are downloaded. I'm waiting for the others to finish. I'm waiting for Sulochana, Prabhat, Peripun, Naveen, Haritha, Lihini. Any one of you do not have the class access code, please let me know, I can share. Right.
Can you please share the link?
Okay. Yep. Sure. The class link I am actually now sharing in the group chat. You can click and log in using your Google, whatever the Google account. Right. Okay. Okay, we'll move on to the next set of examples, right? So you can go through with the same document, right? Now the first thing I have discussed is vectors, which means one-dimensional arrays. We can call that name from this point onwards, one-dimensional array. The next thing I'm going to create, I'm going to use a code window again, but this time I'm going to demonstrate what we call a column vector. So it's like you have only one single column, but there are many rows like this. So in this particular case, to create a column vector, I'm actually going to use simple B to represent this one. By the way, you have to use import NumPy as NP. You have to have this always. I'm going to create a column vector called B using np.array method, and within brackets I'm going to have the vector. Now remember, I told you I'm going to have a column vector, which means we have one column but many rows, right? When you have many rows, remember, for each row we have to have a list. Now for example, if you have one, let's say that's only what we have in that column, then 2, another list, 3, another list, sorry, we'll put 4, this is exactly what I have in the code, and then we'll have 5, right? Now you can say print B, you can observe run, you can click run. When you click run, first iteration it might take some time depending on your internet connectivity, as well as it will initialize the environment, but after that it's quick, right? So you will see like a column vector. So you will have one column but you have many rows. So each row we represent using a list. Actually we will have a list of list here, right? Slightly different from the previous one. Now you can type all the other methods that I have used. I'm not going to try everything. but you can try some of these ideas whether you could get the same answer. Let me have a few. If I get the shape, right, that means the dimension, it's this time you get 4 and 1, not like previous case. This 4 means you have a number of rows. There are 4 rows and 1 column. That's why this is 4. It's a 4 by 1, right? And then similarly, if I get the size, that means the number of elements, you'll get 4. So make a note of this one. So this is the dimension actually. Dimension. And this is, I'm putting comments, number of elements. Right. Right. If you have finished up to this point, can you please indicate by raising your hands? Prabhat, Vishaka, were you able to download the handout?
Yes, sir. It's okay.
Anyone is having any issues of downloading this handout from the Google Classroom? Right, okay. Now, this is about the column vectors. Now, the next few functions, I'm going to talk about how to create, how to generate these vectors. So, sometimes we have to arbitrarily, change or create vectors and matrices. For example, in data analytics, sometimes we have to randomly select a set of features, which we can do by using generating a set of random vectors. So similarly, in numerical Python, there are some functions where we can actually create. So what I'm going to discuss in this part, functions for creating vectors or generating vectors. Right. First one, I'm going to discuss array. Remember, range function similar to that, but this will create arrays. Now, for example, let me say I'm going to create a vector called 1 to 10 vector. I use this name to reflect that I'm going to create a vector, but that vector containing numbers from 1 to 10. So the method I have to use is np.arange. Remember, the range function similar to this. Now, for example, if I want to get values from 1 to 10, we can have start and stop 1 and 11. If I do this, and if I say print 1 to 10 vector, if you do that, yeah, you are getting something like this. So vector generation is an interesting function because you need sometimes to generate vectors. So you should know which ones to use. So in this case, we are going to actually talk about two functions. The first one is arange and the second one is linspace, linear spacing, which I will discuss after this one. A quick question, right? If I want to print odd numbers, what I should change from here? From the previous knowledge, you can guess. Let's say I want, instead of printing 1 to 10 vector, let's say I need a vector containing only odd numbers.
(1,11,2).
Yes, exactly. So if you remember the range function, similar to arange as well, we can have three values. We can have a start, we can have stop and step. So if I put a comma, 1, 11, 2, which will give me only the odd numbers. Yes, it's possible. So let me create a separate vector for this. Let's say a vector with odd numbers. Let me say simple C, write np.a range. I can say okay 1, 11, 2, and if I say print C, C will contain only the odd numbers. So if I want to print odd numbers from 1 to 100, which place I should change? So if I want to print odd numbers between 1 to 100, for example, you can put 101 here. In that particular case, you will get a vector containing numbers from 1 to 100, odd numbers from 1 to 100. Similarly, if you want to have even numbers, you can change the starting value, right? You can go like this. Similarly, if you want to go other way around, like from 10 to 1, remember we were discussing, right? We can put 0 and we can have -1, right? We'll get numbers from 10 to 1. I think you should play around and should be familiar with how to make use of a range function. Right, if you understood well this function, yes, can you please raise your hands? If you have finished up to this point, can you please raise your hands? Okay, right, that's good. Anyone having any issues of this? Okay, I'm going to switch back to these two odd numbers. So I said vector with odd numbers. So let me change this as odd vector. So I can put 1, 11, 2. So since I changed the name, I will put odd vector here. You can use any name, but make sure that you follow the rules which will create variable names. Right, okay. So I'm going to discuss now the second method, which we call linspace or linear spaces, which means this method will get starting value and end value, will create linearly spaced values in between. Okay, so for example, if you want to print 50 elements, that's the basis, right? Let me create a new code window. So the function we are going to use is called linspace, linear spaces. Linspace means linear spacing. We can say could be used to generate linearly spaced vectors. Right. Now let me show you. Now let me create a vector called y. The method is NP in numerical Python linspace. You can see the details here. It says the linspace start, stop and number of points. So let me just put a start and stop. So we can say 1, 100. But remember, this is slightly different from a range. In a range, for example, if you put 100, it will go up to 99. But this is slightly different, this method. It will include both 1 and 100. Right? So if I say print y, you can see here are the details. Right? You will get values between 1 to 100. This number of elements, actually, if you can use print y dot shape, you can see it contains 50 elements. So that's the basis. So whatever you give here, the two values, start and end value, in between it will create 50 elements. So that's how it works. So the default value is 50. Now for example, if I put 0 and 1, let me put 0 and 1. So it will create 50 points between 0 and 1. Right? That's how it works. Whatever you put. So I'll go back to 1 and 100 again. So it will create 50 elements between 1 and 100. Any questions, please? Now remember, the values are floating point numbers. So you see here this one indicates 1, but it's a floating point number. So that's why the decimal point is there. So for example, if you need 100 points between 1 to 100, then I could change this. So here is I'm going to change. I'm going to say this time y equals np.linspace. I'm going to say 1, 100, okay, as the third one you can put 100. So the third parameter which will define the number of elements. So this time we are going to say 100. So if you print y this time and if you run it, you are getting exactly values from 1 to 100. So the total number is 100. There are 100 points or 100 elements between 1 to 100. Right. If you have finished up to this point and if you are comfortable, can you please raise your hands?
So it is giving 8 decimal places. Is it any significance about that?
That's the default one. Default values. Okay. When you make a division also, you will get some number, right? Now, for example, if I take like 10 divided by 3, if you put it like this, you will get this many, precision. But you can limit always with, using print statement, depending on the way you want. Or else you can put, So there's a method now. For example, let's say I want to have integers, not decimal points. Then what we could do, let me try. Y equals np.linspace. Let's say I need values from, D type. We can say 1, 100, 100 points. But I can say that I need it as a D type. I can say I need it as an int. So I can put another parameter here to say that I need it as int values. So if I put int here and if I run it, okay, I couldn't put print y. If I put print y, this time we'll get the same one, but this time the numbers are as int values.
So I have a question.
Yes.
What is the difference between 1, 100 and 1, 100, 100? Can you
Okay.
get that?
Yeah.
Yes.
Let me explain again. Now, when you say y equals np dot linspace, and when you put a bracket, usually you get help. So in the help, it says everything. It says the first value is to indicate the start, second value to indicate the stop. Okay? Did you got my point?
Yeah.
So if you specify 1, 100, right? If you include these two, other values are default. The default values are number is 50. That means it will create 50 elements. So if I get print y, so in print y we will have 50 elements. Right? We have 50. If you count it, you don't have to count it. You can say just y dot shape. If you remember the shape command, it says it has 50 elements.
Okay.
Yeah. Then if you include another value, the third argument, when you say a comma, it will give you. So that's, we are going to specify the number. Right now the number is 50. So when I put 100, it will give me 100 elements. So it will be 100. So if you just use y, you can see we will get numbers from 1 to 100. We will get 100 elements. So by changing this number, you can decide how many elements you need. Understood?
Yeah, it will print only the odd numbers. Previous case, no? 50 numbers, 50 odd numbers. 1, 3, like that. Is there any pattern for that?
No. It's linearly spacing. Now linear space means like you have a length. Now let me give you some practical example. Let's say I'm going to drawing we will do as the next part. We need some intervals between 0 to 1. Let's say we need 50 points. And this function does exactly that. Now when you draw some curves, right, let's say sine function between 0 to pi, let's say I need like 50 points. So I can say 0 to pi, and then you can third one we can put 50. If you put 10, it will give you 10. Let me show you. 1 to 100, I put 10. So now it will print only 10.
Okay.
Right? You got the point, right? So if you need only 5, so you could put 5. See, 1, 2, 3, 4, 5.
Thank you.
The beauty is like, now you will realize that now these methods we will continuously using in drawing, for example, in MATLAB for drawing. So between 1 to say 0 to 1, if you need 5 points, you can put 5 here. If you need 50 point, you can put 50. So then we can define something else. Okay, let me show you that one as well. Let me put x here, x and y. I'm going to say, okay, 1 to 100. I will put, 5 points. And then I can say, okay, y equals, right, 2 into x, right. So let me say print x. Hopefully this will work. Print y. You see the point now. So the x values are 1, 25, 50, 75, 100. Y is 2, 51.5 and so on. If you need, let's say, 100 numbers. So the values, x values are 1 to 100. Y values are 2 to 200. You got the point, right?
Yes.
So sometimes mathematical equations we want to put values and you can get the output, especially in Excel also. Like when you want to draw something, you define what x values are, then you define y values are, and then you can draw. A similar thing could be done here. You have a control over how many data points that you need to have. So when you put 100, it will create 100 data points. Okay. Right. Anyway, thanks for asking a lot of questions, because then only you exactly know what happens with these methods. Right. Now that we have learned about the vectors, I'm going to talk about matrices. Now matrices is very, very important, because for example, our data sets are actually, in a way, if our data sets contains only numerical values, you can think them as a matrix, right? So simply they are 2D arrays. So let me say, let's say I'm going to create a vector matrix A with np.array. So the method is I can create using list of lists, like we discussed earlier, right? So within that, for each row we can have a list. So for example, let's say I have a first row 1, 2, 3. Then second row, let's say 4, minus 5, 6. Then third row, I can, let's say 5, minus 6 and 7. Right? So this is how we define the matrix. So if you print A, you can see this will create a 3 by 3 matrix. Okay. This should be capital A. So that was my mistake. Sorry. You get 3 by 3 matrix. So how do you know? For example, if you get print a.shape, will give you the number of rows and number of columns. So it says it's a 3 by 3 matrix. Any questions on this one, please? Can one of you tell me how can I access the value 1 here? Let's say I want to access first row. Can you tell me how could I do that? So let me say print a note. If I put it, you will see that this will give you first row, right? So this is first row. Similarly, if you need to access second row, we can say A1. So there are two ways that actually you can access elements. So one is you can comma separate like this. Here we say 0, comma 0. 0 indicate first row, first column. Or else the other technique is you can simply say a note, which will give you the first row, and with that you can get 0. So both cases you are accessing the first element, right? Access value in row 1 and column 1. Index, we are using index here. So if you put this one, we are accessing first 2 rows. And simply I told you earlier, you don't have to specify the beginning. So just you can say colon and 2. So this is enough. This is interesting and shortest way you can access the first 2 rows. So we have learned how to create matrices using numerical Python array method, and we discuss how to access elements in this matrix. Right. Any questions, please? If it is not clear, please let me know. You can try one at a time. Now, for example, if you want to handle images, so this is exactly how we could do. Images are nothing but, matrices with some numbers. Let me show you some examples where the method is used. I'm going to show you some of the notebooks I have prepared for image handling. So let me show you like some images. Right, not everything, but for example some of the codes. So for example here I'm actually getting some image. I will read an image here. So these things, and then when you want to print a part of the image, you can say number of rows you want and number of columns you want, right? So for example, the image processing is nothing but you process or you work with a lot of numerical matrices, right? So you can see like a lot of bunch of numbers are there, but the simply idea is you can use it, right? Now for that, actually in my case, to access these images, I have used Opencv Python library for this, and you can see this is one of my images, and you can see it's a 3-dimensional one, because the color image you can see usually as a 3-dimensional image. Hello.
Hello. Sudhira katakan electrical lagi.
Oh, Sudhira.
Katakan
Sudhira මම lecture එකේ ඉන්නේ. මම ඉවර කරලා වට ගන්නද?
හරි එහෙම.
හරි. ෂුර්. මම call එකක් දෙන්නම් ඔයාලට. හරි. Right. So all these are numbers. Like you don't need to know everything, but so all these images, image manipulations are like manipulating numbers in matrices. So it's very important in a way. Like for example, this is a frame, but frame is actually defined using a bunch of numbers. And you know, putting a frame into an image means you just add those two matrices together, right? So if you look at and you know, face recognitions, again similar, right? So the faces can be recognized. Again, everything is happened within these matrices, right? It's again matrix manipulation, right? So the matrix generation is very, very important, and we should know. Now the cropping, let's say sometimes we'll take part of the image. Part of the image means you are selecting number of rows and number of columns. Now similar to here, I think now you should know how to read this part. Simply we are reading from an image, you know, first 100 rows and the first 73 columns, and then you will get a part of the image. So those are the things that actually we will learn. Sometimes you might not understand why we are learning, but when you go work with the data, then you will realize that these methods are very, very important for you to work with data, right? This is just for your, you know, just to show you that the uses of these matrix manipulations, especially the matrices, and especially sometimes even the text. The text are also, when you want to analyze text, are also we represent in mathematical form. So there are techniques we have to convert a text into a matrix form. So that's possible. And the data sets, definitely they are in matrix form, especially if you have a numerical data, right? You can directly use it as it is. Right. Any questions, please? Right. If you do not have any questions now, let me show you or share some of the matrices could be used to generate matrix, right? Like vectors, we will have matrix generation functions. Now, for example, what I'm going to discuss here, generating matrices, which means now, for example, you need to create sometimes matrices. For example, if you want to create a matrix filled with numbers, right? We can create like this. Now, the methods are, I'm going to use np.ones, for example, something like this. np.ones, and if you put 5, I'm directly using this, you will get a vector containing 5 elements, but everything contains ones, right? Similarly, you can have np.zeros. If you put 5, like here, you will get a vector containing filled with zeros. Right. Now, if you want to have a matrix, then you have to define both rows, number of rows and columns. So, for example, I can say, let me create, let's say, matrix B. I'm going to say np.ones, Now the first one is you have to put the dimension. Let's say I'm going to have a 3 by 3, right? And if you print B, you will get 3 by 3 matrix filled with 1. Now let's say these ones, usually when you have decimal point, it means we are getting floating point numbers. Now let's say we need integer numbers. You can simply change this. We can say B equals np dot ones. We can say 3, 3. Right? That means 3 by 3 matrix. 3 by 3 means number of rows 3, number of columns 3. And D type, I can say int. So when I put D type int, this time this matrix B contains integer values. So I think you better take your own notes to understand this. If you are done up to this point, can you please raise your hands? Piripun, do you need any help? Prabhat, Saumya? You okay? How about Lihini? Just change the numbers and see. You don't have to type whatever I type. You can change, like you can create 3 by 2 or like 4 by 4, You can play around with, these. Right. Thanks everyone. We'll move to the next one then. There are a few others you can try. I will just show you a couple of them. For example, we will have identity matrix. Those who have done mathematics, if you don't know, just forget about for the time being. Now, for example, if I say identity matrix, we can create using EYE. Now, what identity matrix means, if you put 3, so it will create 3 by 3 matrix where the diagonal elements are 1. Diagonal elements means these elements are 1 and all the values are 0. For example, if I put 5 here, it will create 5 by 5. All the diagonal elements are 1. Right? So this is called identity matrix. Finally, I would like to discuss random numbers. Random matrices are very important and it's used many places. In machine learning, for example, there are methods based on these random matrices like random projection, random forests, random rotational forest. There are methods like that where you need to use this random matrix. So we should know how to create random matrices here as well. Now sometimes we need to artificially generate data, isn't it? Sometimes in your problems, we need to artificially create data. Simply we can make use of these functions that we are going to discuss here. Right. Now, if you need some random numbers based on some distributions, for example, if you need like uniform distribution, and we can use of normal distribution. So there are two methods that I'm going to discuss. First one, let me discuss random numbers from a uniform distribution over 0 and 1. So the command is, let's say I'm going to create this one. I'm going to show you a vector first. I'm going to have random dot rand, and if you put 5, that is number of elements. So if you say print d, so this will create a random vector containing 5 elements, 1 2 3 4 and 5 elements. Similarly, if you need a matrix, let's say capital D, I'm going to say np.random.rand. Okay, this time you have to specify number of rows and columns. So let me say 3, 2. So I'm going to create a random matrix with 3 by 2. Right? So if I do that as the second one, you will see in the second one you will get 3 by 2 random matrix, and value range from 0 to 1. Right. Similarly, the other way of creating a random matrix, we can generate random matrix based on uniform distribution. Right? Normal distribution. We discuss uniform. Now, similar way, there are other methods which we can use random numbers from a standard normal distribution. So we can say d equals np.random.rand. N should be n rand. It's a normal distribution. So if you say 5, and if you say print d, so this time the values that you are getting based on normal distribution. Similarly, if you need a matrix, let's say D, np.random.rand n, we can say 3, 2, which will create a 3 by 2 random matrix. We can say, okay, print D. So if I rerun it, yes, so this is what we will get with random matrix. Right. Finally, if you need integer values, there's a method called randint. Now, for example, to get random integers, we can say, okay, d equal np.random.randint. We can say 1, 100. This will give you just one value. it basically gives you a number between 1 to 100. Yes, 1 to 100. Every time when you run it, you will get different values. Right. Similarly, if you let's say 10 elements, we can say, for example, d equals np.random.rand int 1, 100, 10, which will give you 10 values. We can say print d. So the second time when we run it, we'll get 10 random numbers between 1 to 100. Okay, right. Now that we have learned how to generate random matrices, right? If you are comfortable up to this point, can you please raise your hands, please? If I finish up to this point. Right, Naveen, Nahil, are you okay up to this point? About Amila and Peripun? Okay, thanks everyone. You can lower the hands. So next part, what I'm going to do, I'm going to discuss accessing accessing elements in matrices. I'm going to create a matrix. First time just manually, and later on I will discuss how automatically generate a matrix like this. Right. So what I'm going to do is I'm going to create a matrix X, retrieving elements from a matrix. Right. So let me say X, I'm going to use capital X this time, np.array. Yes, matrix is list of lists. We can have 1, 2, 3, 4 as the first row, then 5, 6, 7, 8 second row, then 9, 10, 11, 12 third row, fourth row, 13, 14, 15 and 16. Right, and let me print X will print the matrix, a 4 by 4 matrix. Later on I will discuss how automatically easier way to doing this, but for the time being let's type it. It's a 4 by 4 matrix. I need you to find answers for the following, right? Access element in third row and fourth column. Third row Right, can you type the answers in the chat? So I have a 4 by 4 matrix. Let's say I want to get the element in third row and fourth column. So how should I type? So when you have the data set like this, that means 4 by 4 matrix, right? When you have 4 by 4 matrix like this, we have 1, we have 2, we have 3, we have 4, we have 5, 6, 7, 8, we have 9, 10, 11, 12, we have 13, we have 14, 15 and 16. Now the question asks you to type to get third row. Third row means this row. Third row. Fourth column. That means this one. Which means we want to get this number, isn't it? So how should you type it? That's the question. Right? Now to do this, right, what we need to get is x, and first of all you have to put the index value. Now what are the index? First of all, the row indexes. Here we have 0, we have 1, this is 2, this is 3. So that means third row means we have to access 2, isn't it? Comma, then we have 0, 1, 2, 3. Fourth comma means 2, 3. This is how we could access, isn't it? Right? So I can, for example, let's see, we can say print capital X. Second row means that is 2, fourth column means 3. So if I say print 2, 3, so you will get as 12, right? We are getting that value, isn't it? Now similarly, I will give one more, right? Okay, let's say I want to access element in first row and third column. Yes, can you give me the answer for this? So I want to give first row. First row means this row. Which column? Third column. See, this is 1, 2, 3, third column. So that means we need to get this one. Saumi, I have actually discussed two ways of doing this. One thing is you can just say x2, 3, that is one way. And you are using the other way, that means you have x first of all 2 and then 3. Both are okay, but make sure that you understand. Right. Now in this case, first row. So I can say print x. First row means index is 0. Then it says third column, that means 2. So if you run it, yes, you are getting 3, right? Right. Can you try to access the third row? How do you access the third row? I want to get everything in the third row. Yeah, there are many methods that people use, so I will list everything. The first one, simply you can say, okay, 0, 1, 2. You can type this. This will work. We are getting third row, 9, 10, 11, 12. Or else you can say print x 2, everything. So when you say everything, it should go from 0 to, yes, how many rows? 0 to 3. You can put it like this, right, to say that everything. Or else you can simply say x 2, just colon, to indicate that you are getting the third row. So everything should gives you the same answer. Sorry, this should be 0 to 4. Right? So this is the starting value, this is the end value, so you can just simply call it. So both ways are okay. Right? Depending on the situation, we might use any of these, but you should be familiar with all these. Right. Okay. Now can you guess fourth column? Yes, how do you get fourth column? That means 4, 8, 12, 16 we need get. So one way to do this, we can say print x. We first of all have to say all the rows, right? So we can say, okay, 0 to 4, comma. Then we can say fourth column, right? Fourth column means 3. Index is 3. So you could have done that. We are getting 4, 8, 12, 16. We are getting this. Or simply, the shortest way is x colon, just give you everything, just put 3. So this is the easiest way you could do, right? Get the answer to access the fourth column. Right, I think now you should be able to, find out any answer given. Right. If you have finished up to this point, can you please raise your hands? Right, okay. I told you I will discuss a simpler way to create a matrix like this. Now can you tell me, forget about the matrix, can you create a vector containing numbers from 1 to 60? What is the code I have to use? Yes? Give me a vector containing numbers from 1 to 60. Can you tell me one way to do this? We discussed 1 to 10. Similarly, how to have numbers from 1 to 60. Yes? You can lower the hands. I want to create a vector containing number from 1 to 60. Can you send me the code for this? Which function we have to use?
Arrange.
Exactly. Right. So we can say, let's say my vector name, let me put as A, right? And then we can say np dot a range. We can say 1, 17, isn't it? So if you say print A, now this is a vector this time. We are getting a number from 1, 60. Start and stop. Right. Now you can say, let's say I'm going to say B. I'm going to say A dot reshape. Now the reshape is you can change the shape. I can say, okay, I need 4 by 4. Right. So if I say print B, see what will happen. Right. So I'm getting numbers 1 to 16. That is the A. A dot reshape. I will reshape this content to 4 by 4. That means with 4 rows and 4 columns. Right? Actually, you can combine these two. So simply I could have typed something like this. I can say print np dot a range 1, 17 dot reshape 4, 4. Easily we could have done like this. Right? So this is how we are getting this. So the trick I have used here is I first generate the elements 1 to 16 using a range, and then I will use reshape command. Reshape means you can use any method that you need to use, you can use it. So in this case I am reshaping the numbers into 4 rows and 4 columns. Any questions on this one? Are you comfortable with this? A range, I hope you already know. It says start and stop. When you say start and stop, it goes from 1 to stop is 17, then it goes up to 16. So you have 1 to 16 values. Then in B, you are reshaping. You change this to 4 rows and 4 columns. 4 into 4, you have 16. 4 rows and 4 columns. Okay, those who have finished up to this point, can you please raise your hands? Right, you can lower the hands. Thanks. Okay, now next part I'm going to talk about few things on changing elements in a matrix. Right? So now that we know how to use this, I can directly create a matrix. Let me say X. I'm going to click np.arange. I'm going to say 1, 17 dot reshape will be 4 by 4. So if I print X, yes, I have something like this. Okay, I need you to do this. First, change the first element in row 1 and column 1 to 10. Can you give me the command for this? Right now, row 1 and column 1 we have 1. I want to change this value to 10. Can you type the equivalent command for this? Right, Prabhat said he is getting an error. Prabhat, are you still get the error?
Yes, sir.
So do you have a comma in between 1 and 70? Now usually if you forgot this, we are getting that error.
Yes, I put the comma
Comma.
in between 1 to 17. Yeah.
1 to 17. And what you say is you are getting an error for here, right?
Yes, that's error message also shown in the text message.
I cannot see anything wrong in your code actually, so that's why I'm wondering like what exactly happens. Try something else, some other values.
This is the same, sir.
Can you share your screen if you don't mind? I'll stop my Can you go to file and create a new notebook? No, not here, not there. Can you go to file? Yes, below. New notebook. Yes, type import NumPy as NP. Enter. So now can you type the command and see?
Now it's
Okay, nothing wrong with the code, something else happened, that's why. You can continue like this. Okay. Okay, can you see my screen? Right, now what I have asked to change the element in 1, 1, row 1, column 1. So to access, we know we have to use index. Indexes are 0, 0, right? If you type x 0, 0, it will tell it's okay. So the problem is I changed the shape, right? Reshape should be 4, 4. Now if I run it, the first element is 1. So what I want to do is I want to make it to 10. So I will say okay, equal 10. That's all. So and if I print x now this time, so you will see the first element, earlier it was 1, now it has changed to 10. Okay, another command, do this. The next what I want to do, change the elements in the second column, to 2. Now second column means this one. I want you to change everything to 2. Can you share me the code? Again, if you are getting errors like Prabhat, what happens earlier, please share your screenshot or the error message so that I can help you. Right now, matrix, this is what we have. I want to change the second column, this column, all the elements to 2. First of all, how do we access the second column? First one, X. You have to say all rows. We can use colon, comma. Second column means index 0, 1. So it has to be like this. So if you run this, you will get in this 2, 6, 10 and 40. Right? So 2, 6, 10 and 40. So what we want to say here is, we want to make it to 2. Simply we can type 2. That's enough. Indika, your one is also okay, but simply you can just say 2. Right? And if we say print X now, you can see now the first element is 10. Second column, now everything is 2, right? Right, another one. Let me put another one. Right, next I want to change elements in the third row to 3. Right now in the third row we have 9 to 11, 12. I want to make third row. Let me say fourth row, because in the note I have given fourth row. Change element in the fourth row to 3. So that means everything in this last row I want to make it to 3. So what is the command? So accessing the fourth row, you can either use 3, colon. Sometimes you can just say 3, that's okay. Both ways you are getting the same. Even if you put this, you are getting the same answer. and we want to make it to 3, right? So that means we say equal sign, we can say 3. So if you print x, yes, now you see last row, it has been changed to 3. Prabhat, index should be 3. 4 will give you an error because index start with 0, 0, 1, 2, 3. Right. Okay, I want to change all the elements zero. So if I go with my notation, rows, all the rows and all the columns. So this will indicate everything. We can say that this should be 0. Right? And then if you say print x, you are getting this. Even you can just simply say everything should work. For example, x colon should work. Yeah, it's everything. So either you can use this, because since we have rows and columns, that's why I use this format, but that's perfectly alright. You can assign it to 0, and at the end you will get all zeros. Right. Let's move on to the next one. In this part, I am going to discuss how to combine matrices. Then now you might be wondering why to combine. So for example, if you have 2 data sets, we can make it a 1 by concatenating. So we will look at how we can combine matrices together. So let's see the example. So I'm going to create 4 matrices in b.array. I can have 1, 2, 3. Sorry, comma 4 comma 5 comma 6 comma 7 comma 8 comma 9. I know now you know how to, if you want, you can generate using the commands that we have discussed earlier. You can automatically, you don't have to type. And this is matrix A. It's a 3 by 3 matrix. Similarly, I will define B array 3 comma 2 comma 1 6 comma 5 comma 4 9 comma 8 comma 7. So this is B. So if you print B, it looked like this. Another 3 by 3 matrix. Similarly, I will define D C 2 comma 1 comma 3 5 comma 4 comma 6. This is a toy problem anyway. 8 comma 7 comma 9. So this is C, right? And D np dot array 2 comma 3 comma 1 5 comma 6 comma 4 then we have 8 comma 9 comma 7. Right, we have 4 matrices, 3 by 3 matrices like this. So if you want, you can print it and see. Print A, print B, print C, print D. Right, we have 4 matrices like this. This is first one, second one, third one, fourth one. Right. Now that we have these 4 matrices, first of all, have you finished up to this point? Can you raise your hands just to see how many of you have finished up to this point? Okay, you can lower the hands. Right. Let me talk about how to concatenate. Concatenate means you combine. Right. Now, for example, if I say np.concatenate, and remember, you have to have within brackets, again you have to have as a tuple, you have to say a comma b. Remember, here we have 2 open brackets and close brackets. So this will concatenate two matrices row wise, right? So when you print it, you will see this is A and this is B, and it will be only one. Only one means you have 6 by 3 matrix. You have 6 rows. Row wise it's concatenated. The same thing could be done with another command. We can say np.vstack. Again, you have to have 2 open brackets and 2 close brackets. The same thing it will happen. You will get this. You will get the same result, right? This will concatenate row wise. Right. Next one. If you want to concatenate column wise, so we can say print np.concatenate. Okay, within bracket we have to have 2 open brackets, a comma b. After the first bracket you put a comma, you will say axis. You can notice in the here axis 0 is row wise, axis 1 is column wise. So I am going to say axis is 1. So when I do this, you will see we are getting now 3 by 6 matrix. So this is A, this part is A, this is B. It will concatenate column wise. Similarly, we can have the same one using another method called hstack. Hstack means horizontal stack. We can say A comma B. Again note, we have 2 open brackets here. You will get the same result. Right. Small question you to think about as a homework. We'll discuss the answer in the next week. Right. Now, we have learned how to put, now we had 4 matrices, A, we had B, we had C, we had D. Now what we have learned so far is how to concatenate row wise. That means like this, AB. Now this one, what we learn how to put in, right? Column wise, that means like this. So these two we have already done. Now if I want to create a matrix like this, A, B, C, D, we know all these matrices 3 by 3, right? I want to create 6 by 6 matrix by combining matrices like this using the method we have discussed so far. What are the method we have discussed? We discussed concatenate and VStack and HStack. You don't have to use everything. Either you will use VStack and HStack, or you just use concatenate. That's all you need to do. I want you to think about this, come up with an answer for this. Okay, so with that, I think we can conclude today's session. We look at numerical Python from the beginning. We left with very few commands. We have the basic matrix operations. That part we will do next week. And then we will start plotting and pandas as the first session next week. And final session, we will discuss machine learning application. Right, so you have a lot of things to read and understand. So I have shared the note with you. Please spend some time with the commands that we have discussed, which is very helpful for you in the coming sessions. So having said that, let's finish for today. Right, we'll meet on next week. Thanks then.
Thank you, sir. Thank you.
Thank you. Thank you.